when you're talking about concentration of a solution, we are looking at the difference in the amount of solute in different solutions. Okay, so how do we calculate concentration? We say concentration is given from mass in grams. You divide the volume, mass in grams. You take the mass, you divide by the volume, which is in decimeter. Okay, so this is one method of expressing concentration, or concentration can also be given by taking the number of moles, you divide by the volume of the solution, which is normally given in what? In decimeter. So these are the two methods of expressing concentration. Now another thing we need to know is the volume that you're talking about here. We have said the volume is expressed in terms of what? Decameters, in decimeters. So normally you're going to encounter volumes, the questions, when you're dealing with the questions, the volumes are either going to be in liters or in centimeters cubic. So we need to know that 1,000 centimeters cubic is equals to 1, okay, decimeter, which is equals to 1 liter, so that you can be able to interconvert, or you can be able to convert the units to the respectable unit, which is decimeter. Now, how do you calculate moles? So moles can also be given. Moles is expressed, or the expression of moles and a concentration of solution, saying the mole is given by taking the concentration of a solution, you multiply by the volume of your solution. Okay, T is simply the number of moles of a solute in 1 decimeter, okay, of a in 1 decimeter of a solution. It is the number of moles of a solute in 1 decimeter of a solution, or in a decimeter of a solution, or in 1 liter of a solution. So the units that are used, or you can express molarity, or molarity is expressed in terms of, so the units of expression are, here we have that two, that one, and as molarity, like that. So let us do one question under concentration and molar solution. We're saying 0.0100 moles of oxalic acid, 0.0100 moles of oxalic acid is dissolved in 100 centimeters cubic, of solution. Calculate the molarity. So you have 0.0100 moles of oxalic acid dissolved in 100 centimeters cubic of a solution. Calculate the molarity. So we are going to write the formula and say molarity is given by, you take the moles of your solute. Molarity is given by the moles of the solute, you divide by the volume of your solution in decimeter. So do we have the moles here? Yes, we have been given the moles. Do we have the volume? Yes, but the volume, is it in decimeter? No. So what do you do first? The first thing you do is you convert your volume from centimeter to what? To decimeter. Okay, now what you're going to say is, or alternatively, so you can do it two ways. The first one, you can say you have 0.0100 moles, 0.001 moles of your oxalic acid are dissolved in 100 centimeters cubic of your solution. So how many moles are going to be present in, 1,000 centimeters cubic of your solution? Because we said 1,000 centimeters cubic is the same as 1 decimeter. So you cross multiply and you're going to get 0.0100 moles. You multiply by 100 centimeters cubic. You divide by 1,000 centimeters cubic. So the centimeters cubic and centimeters cubic cancel out, and you're going to remain with 0.100 moles. Or now your answer, you're going to say it is 0.1 molar. Now that is the first method you can do when you're calculating concentration of a solution, where you are going to say this amount of moles are found in this amount of volume. So how many moles are going to be present in this 1,000 centimeters cubic of we have said the volume, or the formula is molarity is equals to moles of the solute in the solution. You divide by the volume of the solution, which is in decimeters. So our volume is in centimeters cubic. Let us convert it to decimeters. So we say 1,000 centimeters cubic is equivalent to 1 decameters. So what about 100 centimeters what cubic? Okay, again you cross multiply, so it's going to be 100 centimeters cubic. You multiply by 1 decameter. Decimeter, 1 decimeter, you divide by 1,000 centimeters what cubic, the centimeters, and that one cancels out, and you're going to finally get your molarity as being of your solid, which is 0.010, okay, mole. You divide by the volume, which is going to be, so when you work this out, you're going to get 0.100 decimeter cubic. So you divide by the volume of the solution, which is 0.100 decimeter what cubic, where you're going to get your molarity as 0.100. Okay, 0.0100. So this is how you work out molarity. The second question is, you have been told, suppose you're given 71 grams of sodium sulfate and it's dissolved in enough water to make 1 liter of a solution. Determine the molarity of the solution formed. And then you've been given the masses of your elements. That's why we said it's important to know how to write proper formula of your compounds. So we are going to say the mass of sodium sulfate. So we are going to say the mass of sodium sulfate, or this is the mass of sodium sulfate, which is 71 grams. Okay, now the mass of 1 mole of sodium sulfate is going to be what? The molar mass, the summation of the masses of these compounds here. So we are going to say how many sodium atoms do we have here? We have 2, so it's going to be 23 times 2. You add for sulfur, we had what? 32. Then you add for oxygen, which is 4, you multiply by 16. So when you do that out, you're going to get 142 moles. It's going to be 142. It's going to be 142. And remember, the mass, the molar mass, is expressed in terms of grams per mole. So our mass of sodium sulfate, in 1 mole of sodium sulfate, you have 142 grams per what? 142 grams per mole. So when you're told to work out molarity, we said molarity can also be expressed in terms of mole per decimeter. We said molarity can also be expressed in terms of moles per decimeter. So we are going to work out the moles in order to get the molarity of our solution, whereby we're going to say moles is equals to mass, okay, which is in grams. You divide by molar, the relative, the molar mass, you divide by the molar mass. You divide by the relative formula mass, which is in grams per what? Which is in grams per mole, or by molar mass, which is grams per mole. So your moles is going to be your mass, the given mass, which is 71 grams. You divide by your molar mass, which is 142 grams per what? Per mole. The gram and the gram cancels out, and you're going to remain with 0.5. Your answer is going to be what? 0.5 mole per decimeter. Okay, or you're going to say the molarity is 0.5 Molarity can be expressed in these two methods.